our last lecture we have seen what is voltage divider circuit in case of series circuit, and the remaining part from that voltage divider circuit is if that series circuit of voltage divider is open and what will happen if that voltage divider circuit is closed. These two conditions we have to study, and we will start with open series divider circuit. We have to see two cases, that is open series divider circuit and open circuit, and second one is short series circuit. Now here one series circuit is shown. It consists of a 10-volt battery source, and R1 and R2 are connected in series and they are forming a loop. And suppose here the circuit is closed. Now if this end of the circuit is made open, then what will happen? Because of this open end, the resistance will become infinite, because now there is no connection, there is disconnection or discontinuity in the connection, and because of this disconnection or discontinuity there will be increase in resistance, and this value of resistance is tremendous. It is about to infinity. It means that when we open the series circuit, then resistance of the circuit will becomes infinite, and we know that if resistance increases then current is decreased. So here there is tremendous increase in resistance due to open end, and hence current value will becomes negligible small or almost equal to 0. Therefore the current flowing through this R1 will becomes equals to 0. Suppose I is the current flowing through the circuit, and because of this open terminal resistance value increases infinitesimally and I becomes 0, and here also I will becomes 0. Therefore the voltage drop across R1, that is, suppose V1 is the voltage drop across R1, then R1 is equal to I into R1. This will becomes 0 as I value is 0. Same is the case in case of R2. The voltage drop across R2 will be given by R2 is given by V2 is equal to I into R2, as value of I becomes 0 due to the open end. I into R2, I will become 0 into R2. Therefore voltage drop across R2 will also becomes 0. This is first case. Now, because of this open end, what will be the other possibility? As this is the open terminal, therefore resistance is very high. Because of this is the first case. Now, second, what we will observe, the resistance value over here is very high, and this resistance value is very high as compared to R1 and R2. Therefore, R1 and R2 will become negligibly small, and hence the voltage which is present here all will come or all will observed here at the open end. Hence, you will find the voltage of 10 volt across the open end terminals. This is the observation in case of open series circuit. Now, short series circuit. In case of short series circuit, Here is one series circuit is shown which consists of a battery. Its voltage is given as 10 volt, 10 volt, and there are two resistances R1 and R2. R1 and R2. Here also R1 and R2. These are the two resistors. Their values are 2 ohm and 3 ohm respectively. Now here we have to short the circuit. We have to short the circuit means what? When we short the circuit, then resistance becomes 0. When we short any circuit, then its resistance becomes 0. As resistance becomes 0, the resistance becomes 0. So current will increase, and this increase in current will give us power. Power is nothing but product of I square into R. Power is nothing but I square into R. Therefore, this power is given by I square into R. Therefore, heating effects will be produced in case of short circuit condition. So, if we calculate the total resistance of the circuit, that is R is equal to R1 plus R2 is equal to 2 plus 3 is equal to 5 ohm is the total resistance of the circuit, and hence current flowing through the circuit, current is equal to V is equal to IR. Current is equal to V by R. Therefore, current is equal to V by R. What is the value of V here? Value of V is given as 10 volt divided by total resistance we have calculated as 5 ohm. Therefore, I is equal to, I comes out as how much? 2 ampere. Value of I is 2 ampere. Now, value of I is 2 ampere. And what will be the value of power? Value of power, we have seen the formula of power. Power is nothing but I square into R. I square, I is nothing but 2 square into R. Value of R is, total resistance is 5. Therefore, 4 into 5 is equal to 20 watt. 20 watt will be the power produced by using this circuit. Now, we will consider the case of short circuiting. If we connect a conducting wire between across B and C, then what will happen? What will happen? This R2 will get removed, and the total resistance across A and C will be 2 ohm. As we know that as compared to initial 5 ohm, the resistance has been decreased by 3 ohm. Therefore, current is going to increase. So let's see in case of short circuiting. Again, we have to calculate I. Value of I is equal to, what is the value of I? V by R is equal to, it is calculated as 2 ampere. And here in case of now resistance value is only 2. Therefore, the total resistance here, value of V divided by value of R is 2 is equal to 2 1 the 2, 2 5 the 10. Therefore, current value has been increased and it has become 5 ampere in case of short circuit. Now we will calculate the value of power. How to calculate the power? Power is equal to, power is nothing but I square R. So substituting values of I, that is we have calculated in case of short circuit, that is 5 square into value of R. Total resistance is, now resistance value is 2. Therefore 5 to 5 square is 25 into 2 is equal to 50 watt. It means that in case of short circuit, power has been increased from 20 watt to 50 watt and it is approximately 2.5 times the initial value. Therefore, due to this high power which is generated during the short circuit, because the resistance value drop downs and the current value increases, therefore there is heating effect in the circuit, and because of this heat produced by the excessive power, the circuit elements may get damaged. In order to avoid that damage, we are using fuse. Therefore, when current increases, this fuse get open and it will avoid the damage of the circuit elements. So, let's revise once again the short in series circuit. In order to understand that, we have considered a series circuit and we have short it. During while shortening, the resistance has been decreased to R. R1 is equal to 2 ohm because we have shortening this by using a copper wire, and the total voltage provided is 10 volt. Now what we did, we have calculated the total resistance of this circuit by using the initial circuit, and its value was R1 plus R2, that is 5 ohm. But in case of this circuit, now this part is removed, therefore the contribution due to R1 is there, and we have calculated the current by formula V upon R. Here only 2 is taken. 10 upon 2, it gives us 5 ampere. That is, in short circuit, only 5 ampere current is flowing as compared to this circuit. And power is calculated by using the formula I square R, that is 5 square into 2, and it comes out as 50 watt. So, if we compare this circuit and this circuit, then in short, the power has been increased 2.5 times and it is going to increase the heating effect, and hence it will damage the circuit components, and in order to avoid this, we are using fuse which will get open when there is increase in current due to shortening. Thank you.